Okay, let's go ahead and take a look at what's going on from last week. We'll start with week 4. Since we haven't gone over this yet, I want to point out some of the key features of these assignments. Okay, so let's start with the references assignment. Okay, this is the first section of your paper that you'll be submitting to me, generalization section. Really anything you submit now is intended for you to get some feedback on so that before you put it into your final paper, you have a good idea about how strong the sections of your paper are. The references is a major first component because it'll give you the source material that you'll be using to write a majority of your research project. Okay, so you should look for references related to your research topic. We'll be finding articles using databases. This is the first part of the literature review, and the literature review is a very important part to really telling the story of your project, what your prediction is, and what other scientists know about the topics that you are investigating. So for this assignment, it's fairly simple. You'll just need to provide 10 APA-style references and citations, but really in practice, this is a very important step because these are the articles that you will be reading to write your introduction section. So let me show you what this should look like. This is a reference page formatted in the APA style, okay? There are a few key features here. One is how it's titled. It'll be titled References, centered on the page. Then you'll launch into your references. They'll be listed in alphabetical order, alphabetical based on the author name or whatever name is listed first to identify the reference. The APA citations are listed this way so that the reader of your paper can access the sources that you use to write your paper. So you'll have the last name of the author, initial of the authors. Do this for all the authors listed. So an ampersand between them, year of publication, name of the article or book, the journal that it came from, other information like issue, volume, and page number. You'll have 10 of them related to your topic. Okay. You have access to more academic material than the common person as a VVC student, which is great news for you. So doing this using databases benefits us in a number of ways. So it allows us to only look at peer-reviewed work or scientific work. They're set up, only to contain scientific work. So they help us automatically cite our references. They have search engines that help specifically find your variables of interest. So I talked about and listed 2 databases that you can use, EBSCOhost, that we can use called, PsycInfo, it's also called. So that's specifically psychology-based articles. And then, of course, you have Google Scholar, a more generally accessible database that has a lot of great features for you. Okay. So I already showed you, how to access this. You just go to VVC, and then you're going to go to the library page, which is, where did we find that again? Academics, right? And then library, okay? And then you'll go to article databases, and then academic search complete, EBSCO, okay? So make sure you log in using your VVC credentials, so that you can actually access it. So make sure you're logged in first. And if you're using Google Scholar, also make sure you're logged in because sometimes that gives you access to other articles. Okay. So again, it's like a normal search engine, but you have other options that you can use to help find more specifically what you're looking for. So we talked about, let's say you're interested in social media and self-esteem. Okay. And you just search for that and you get a bunch of results, right? You can edit your search, refine your search results. You can toggle different things on and off about, looking for only peer-reviewed journals, looking for only full text articles. I'll let you cheat with that for now, in this class. So sometimes it'll only give you a portion of the text, right? You want the full text. So you might find one title like When Every Day is a High School Reunion, Social Media Comparisons and Self-Esteem, okay? You might find one, Can Self-Esteem protect the well-being of women in their 20s from the effects of social media use, right? So once you find something you want to look at, you can click in, and this will give you lots of different information, the title of the article. You can download the article as a PDF, okay? Keep a copy for your records. Look at more work from different authors. Download these, straight to your Google Drive or straight to your desktop. It'll give you an abstract usually. Yep, there you go. Okay, so it's a great place to begin when you're reading these articles to get an idea of what they did in their study. entire article might be here. I don't know. I didn't search for full text. But, if you do search for full text, the entire thing is going to be there. So, when you're citing, don't use word for word. Look through these articles, see what the major findings are, see what the key elements of these studies are. In addition to just collecting your references, you should also be collecting some information on the findings of these articles, so you can keep it organized. So that will help you write your introduction citation and the rest of your paper. If you take a look at this article and you decide you want to use this for your project, you can click the Cite tool. Remember that? Cite tool, right? And find, the APA 7th edition and copy and paste and add that to your reference list. Okay. So be warned, automatic citation tools are very helpful, but you still often need to do some formatting, generally at the end. So, okay. So then we also talked about Google Scholar, right? So we hop over to that, scholar.google.com, right? So you can, again, social media and self-esteem. Okay, so again, you can read the abstract. If it has these, remember it's full text, or you can search for it somewhere. I know there's a place where you can search for it. But anyhow, this one you actually have to sign in. Interesting. You don't always have to do that. But you get the idea. It works the same way. So for the reference assignment, you need 10 of these formatted and packaged nicely into that template that I gave you. Okay, 10 APA citations. Make sure you look for more current work. So, anytime since something in the past 10 years, really, that's considered recent research. So, yeah, I think we've probably went over all of this. Just trying to think. So whenever summarizing an article, you might want to know, should you focus on mainly summarizing the discussion portion or the methods, the portions of the articles? It is kind of going to vary a bit on why you are sourcing that particular article. So for example, if you're sourcing the article because their method is similar to yours, you definitely want to include some summary of their method and explain that they did this in their method, so that's why we did this in our method. But generally speaking, you really want to focus on the results and the discussion. If you're going to cite an article, you should really be citing what they found. Okay? It is context dependent on what you're using the source for, to back up some theory in your introduction or to back up your methodology. But generally speaking, you want to hone in on the results and the discussion section. Okay? So again, you're collecting 10 references. They should be references related to your topic, but you're not tied to these references. You don't need to use them in your introduction or anything like that. I mean, you can, but you don't have to. It's just our first step into finding articles, getting you some practice, and hopefully finding you some solid articles to move forward with. So I'm saying articles. You can also find things like books, but generally speaking, our main medium of communication in scientific writing is scientific articles in journals. So that's what I want you to use for this paper. You'll notice that's what most of these are. The main thing we want to work on is not just going straight to Google and typing in your topic, because you'll find things that are not peer-reviewed, that are not scientific. You might find blog posts or news articles or opinion pieces, which can be interesting, but they're not what we need for research. So we want to get good practice here in proper research citation. Okay. So we're going to be doing a statistics review, right? The purpose of this particular lecture is just an overview of the major branches of analysis that we have in statistics. So I want to mention a few of them here. Just trying to go back to the page. So we really are going to be honing in on different types of tests. The major types of tests are determined by the type of data that you're going to be using in your study. Okay. So, categorical versus ratio, continuous data, okay. So I have the major tests in the lecture that's coming up, okay. There's really only 4 major types of tests that you might run. Those are the only 4 that you'll need to be truly familiar with: t-test, ANOVA, correlation, and chi-square. So if you've taken statistics before, or if you're taking it currently, those are the 4 major hypothesis tests that statisticians use to address questions in data, and that's all you'll be needing to use for this class. So we make predictions. Our predictions often have a direction. Let's say medication is, let's say you found a new chemical that you think is going to help people sleep better, but you're afraid it might also disrupt people's sleep patterns. So with a hypothesis like this, that it's going to affect people's sleep, you don't know if it's going to improve sleep or reduce sleep, but it's going to affect sleep one way or the other. So that would be a two-tailed hypothesis. If you're working with something that had already been shown to show some increase in sleep, your prediction would perhaps be one-tailed. You're predicting a specific direction of the effect. So whenever you have a prediction, that's your research hypothesis or your alternative hypothesis, that's what you're expecting to see, okay? So in statistics and the mathematical portion, we work with two hypotheses that are, the inverse of each other. The null hypothesis, we'll have our prediction, social media negatively impacts self-esteem, and then we'll always have that counterpart, the null hypothesis, where we say that social media has no impact on self-esteem. So of course it always seems a little funny to have these two statements that are contradictory to each other, but what we really do is test our statistics against the null hypothesis. We're basically trying to prove that there is in fact some relationship or difference. So we say that statements are innocent until proven guilty. We work around the null hypothesis or this baseline of no difference and no relationships. So we'll also be talking about p-values, okay? So P stands for probability. It's often an overcomplicated concept, I think, but when we talk about a p-value, all that it is saying is it's a probability that we observe a difference. So when we have a p-value of 0.05, we're basically saying that a difference or a relationship needs to be so strong that we only have a 5% chance of error. So that's how you can think of this p-value. 5% is a very low probability of it happening by chance, a low likelihood that something could just happen randomly or by luck, good luck or bad luck. So in our case, if we're going to say that social media negatively impacts self-esteem, we would need the numbers to be pretty convincing. We would need the difference to look like it's more than just due to chance of difference between social media users and non-social media users. Okay, so I talk about a coin flip example, right? If you call heads or tails, you know the likelihood's the same, 50%. So if you continue flipping a coin again and again, keep getting heads, at some point you'd be a little skeptical and suspicious, right? You're not getting all of this by chance. Maybe I'm getting some of these due to, something else. Maybe this coin is weighted or a flip coin. Okay, so the same idea stands in the rest of our analysis. We'll talk about this more in the actual lecture, but we want to make sure that these behaviors that we're observing in people aren't just due to chance, but that there's actually something driving that difference or relationship. So how much convincing would it take to make you believe that a coin is weighted? How many times would you need to flip it and see the same outcome before you start to raise your eyebrow at it? For most people, they'll say after about 5 flips, they'll start to raise an eyebrow. And if you take a look at the probabilities, flipping one tail, there's a 50% chance, getting 2 in a row is 25% chance. The more subsequent coin flips you get of the same outcome, the less and less likely it is, the more and more skeptical you might become, and the more you might think that there's actually something fishy going on with the coin, okay? So we map this idea onto behaviors with the 4 major tests. Okay, so we have t-tests, right? That compares 2 groups, 2 separate groups or discrete groups. For example, if we're going to stick with my hypothesis that social media leads to decrease in self-esteem, you can compare 2 groups. You can compare non-social media users to social media users, compare their mean levels of self-esteem. Should be a nice and elegant little t-test. So you're comparing 2 groups, a nominal variable like social media users and non-social media users, right? And compare the main differences across the groups. And so the question we're really trying to ask is to determine if those 2 groups are similar or if they're different, okay? So thinking to the null hypothesis, is there no difference between the groups? Are they virtually the same, or is there a difference? Are they distinct from each other? You can use this, you can test this using hypothesis testing, okay? So the t-test compares 2 groups, comparing the means. All right, so we have ANOVA. Again, I go into this in more detail in the lecture, but it's much the same as the t-test. We're comparing means across groups, but ANOVA can specifically compare 3 or more groups. So maybe instead of having no social media users and social media users, you have low, medium, and high social media users, and compare them this way in 3 groups. So ANOVA stands for Analysis of Variance. I have a friend who has a dog named ANOVA because that's just how much of a stats nerd She is. So we're looking at variance. ANOVA is just looking at variance in every possible form. How our values vary between each other, within each other. We're basically looking at discrepancy in the data, spread from the center. We want to see if our groups are different or the same. So we're trying to see if we split people into distinct groups, 3 or more groups. We want to see if any of those groups are significantly different from the others by just looking at mean comparisons and variance comparisons. So then we have correlations. You'll hear me spout off a lot about correlations. Correlation is a very misused term. It's because people don't really understand what goes into a correlation. The type of data we have dictates what type of test we can run, and that's true for correlation. So if we want to run a correlation, we need 2 variables that can vary on a numeric scale. So for example, we can never run a correlation between gender and something else because we don't have a continuous scale for gender. We think about this with any group where we have distinct categories. Okay, generally speaking, correlations work in such a way that we're looking for, as if one variable rises, does another rise with it or fall with it. So we could structure social media and self-esteem such that we ask people, how many hours are you on social media a week? That gives us a continuous scale. We can also ask people, how's your self-esteem on a scale, something like 1 to 10, and then we can compare the two. So as social media time increases, does self-esteem decrease? That's what we would be looking for. We can see different shapes of relationships. We can see positive or negative relationships between the two, depending on the direction of your prediction. So then chi-square tests, okay, this looks at nominal or categorical variables. You run it when you have a set of categories and when you're looking at frequency of said categories. So chi-square looks at something specific. It tells us if the frequencies or the number of things that we observe are equal to what we would expect. So maybe you want to compare if there are gender differences in preferred mediums for information. Maybe there's a difference in preference between learning information from books versus online in men and women. So in this case, we're comparing one categorical variable, gender, to another categorical variable, learning medium, and we compare the counts. We see if there's a different frequency for each. So we can run a statistical test or a probability test to see if there are significant differences, okay? So yeah, we'll be doing a lot more practice with these things as we go. Again, watch the full lecture on this, but this is the time that we need to start refamiliarizing ourselves with these statistical terms as we move forward, and familiarize ourselves with the type of data that's needed for each of them to be run, so you can start thinking about what tests you are going to need to be running on your data, right? If you have any questions, let me know.